Hello everyone, welcome to binary squares tutorial. This is a three-stage module. So since each of these three stages is basically the same process, I'm going to show the first stage with the normal manual and the second and third stage with the optimized. But what your goal is so for each stage you're going to get the filter according to some rules, then apply logical operators to the grid based on that filter to get the new result. So basically each stage consists of two substitutions. So yeah, I don't remember myself, but I will just remember in a moment. So we would follow these rules in order, and in total we would have 3 rules applied. If there are more than 4 white pixels at this point, if the top left pixel is either black, white or blue, no, it's red. At this point apply filter 3. So what is applying a filter? I'm going to write down the grid. Then I'm going to write down the filter itself, in our case filter 3, black, white, magenta, green, cyan, red, blue, magenta, green, red. Applying a filter. To apply a filter, first create a modified filter by XORing the current grid's pixels by the respective pixels in the filter. So all we need to do is just XOR the current grid and the filter itself. I hope you know what does XORing colors mean, because each color can be represented in each color has RGB values, 1 or 0. We basically XOR those. So red and black is red, red, yellow, white and green is magenta, black, magenta is black, cyan magenta is yellow, green magenta is white, green is black, magenta green is white, yellow cyan is magenta, black red is red, blue is black, red magenta is blue, blue green is cyan, and red magenta is blue. Then we would need to apply the operator of each color in the modified filter to the current grid's respective squares. So what we would need to do is, in the modified filter, take its color look up its operator and apply that operator to the colors from the same position from the current grid and I forgot which one. And I guess modified filter itself. So let's start with XOR. The way I do it is not just in order, but look up one operator. So I'm going to look up all reds and all greens first. So it's going to be red and red, black, red and red, black. Then we have red and black, red, and we have no greens. That's crazy. So we're done with XORs. Now let's do ORs, which is going to be blue or black. So black, we have black here, so black or magenta is just magenta. Black or green is just green. Blue or red is magenta. And blue or magenta is magenta. Yep. Now let's do XNOR, which is magenta or yellow. Okay, yellow XNOR yellow is white. Magenta XNOR green is black. Magenta XNOR black is green. Yellow XNOR cyan is green. Magenta XNOR yellow is no, it's red. That's it for XNOR. Oh, and I missed this black in here. Black was OR. Black or blue is just OR. And now we only have AND left, which is cyan or white. Yeah. So white and green is just green. White and magenta is just magenta. And cyan and blue is just blue. And let me actually look up if I remember this correctly. I'm just double checking to not be like an idiot. So after the first, we have black, black, white, black, green, magenta. Yeah, seems like it's correct. So yeah, so the way you apply a field, you do a stage is XOR current grid with the filter, and then use the operators from the modified filter. Let me actually write this down. Current grid, filter, modified filter, new. Yeah, you XOR filter with current, get modified filter, then use the operators based on the colors from the modified filter, and use those operators on the colors from current grid and modified filter to get the new grid. And this is how you do a stage. Now new current grid is just going to be this. And now let's switch to the optimized. And while it's loading, let's determine the next rule. At this point, which means in our new current grid after the previous applied filter, if the sum of the digits in the serial number is odd, no. At this point, if there are more green squares on the top two rows, we have 3, and the bottom two we have 1. Yes, this is true, so we apply filter 5. Hello? Okay, filter 5. How does this work? So the way, because of the way the filters are actually applied, this entire module can be just simplified to the entire stage can be simplified to a simple lookup. All we do is just in the current grid take the colors in order from left to right. So black. Okay, how do I highlight this? Black, black, white, black, green, magenta, green, 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 magenta, red, red, blue, magenta, blue, magenta. And this is just going to be our new grid. So we write down blue, blue, yellow, blue, green, red, cyan, cyan, black, blue, red, magenta, black, blue, blue, magenta. And let's determine our third filter. So we were at rule 5. At this point, apply filter 6. Okay, let's do the same thing. Blue, blue, yellow, blue. Green, red, cyan, cyan. Black, blue, red, magenta. Black, blue, blue, magenta. And this is going to be our answer, because it's only 3 stages that you need to do. The more you click the squares to change them, I don't really know what the order of the colors in the module is, so it's kind of inconvenient to look for the color you want to submit on each position. We just have to cycle it for a long time. So we have blue, blue, green, cyan, black, magenta, green, cyan, green, blue, red, blue, black, blue, blue, magenta. Okay, and this is our answer. However, there is one interesting thing about this module. By the end, if you have mistakes, this screen on the right will show you the positions of the incorrect colors. This is the table. It will show these symbols which you have to decode into positions. And obviously, it's quite easy to. So basically, each color, well, almost does not correlate with any other colors, except for the rules that care about like how many colored squares were at some point. But if you have like an incorrect color somewhere, you can just go back to stage 1 and work with that color alone, and it will be very quick. If you have a lot of incorrect colors, that means you most likely did an incorrect filter at some point, and you have to redo the module again. And one more thing, if you have actually 4 or fewer mistakes, you will not get a strike. So let's mess up these 3 colors, for example. And this thing shows you positions of the incorrect colors. So these 4 positions, 14, 15, and 16. Let's return them back to their spot, and I don't remember which supposed to be. Blue, blue, magenta. Okay. Okay, and this is how you solve binary squares. Thank you for watching and have a nice day.